Press pause and answer the question.
So they've given us 2 points, here and here. And even without, of course, on the exam, you may not really want to spend the time graphing those out. But just so you know, they're here and here. And we want to find the midpoint here. So how do we find the midpoint? It's actually a really easy thing to do. And if you don't know how to do it, it's most likely because you don't remember how to do it because it's been 3 or 4 years since you did it. But it's pretty straightforward. We find the average of the two x values, and we find the average of the two y values, and that becomes the midpoint, right? So for finding the midpoint of these two values, we're going to take x1, which we'll call that -5, and we'll add that to 1, and we'll divide that by 2. And that's our x value of the midpoint. Our y value is going to be y1, and we'll add that to y2, and we'll divide that by 2. And you see on this one, -5 plus 1 is -4 over 2, and that's -2. So our x value is going to be -2. That's the center point, which works out well because if you look, that's a common choice in our solution choices. All right, now for the y value, 3 plus 6 is 9 over 2. So 9 over 2 is 4.5. So our midpoint is going to be -2, 4.5. Good. Now we have to figure out the area. So we have these 2 points that are the endpoints of a line segment that make up the diameter of this circle. And so we need to find out how long is that diameter, and then we can cut that in half and we can figure out what the radius is. Now, if you have any 2 points in a Cartesian plane like this is the formula for figuring out the length of that line between the 2 points. But I actually think it's easier to remember and no more difficult to calculate if we kind of make everything kind of a Pythagorean world, right? So we're going to bring out the Pythagorean theorem, which really wasn't invented by Pythagoras, but he certainly is one of the ones who popularized it. And we're going to take our line here and we're going to say, okay, we want to go from here to here. And really what we can do is we can make a triangle out of this, a right triangle, and make that the hypotenuse. So we'll put a line here, and we'll put a line here. Now this line here goes from -5x to an x of 1. So we can say it's 1 minus -5. It's 6 long. We know that's 6 units long in this dimension. This one goes from 3 to 6. So we know it's 3 units long. So we know that this line here, which is the hypotenuse, is also the diameter. So we also know that if we take this number squared and we add it to this number squared and we take the square root of that, that's our hypotenuse, right? Because a squared plus b squared is c squared. So a squared, we'll call this a. A squared is 6 squared plus b squared is 3 squared. And that gives us a c squared value of 45. Now, of course, we're going to have to square root that to figure out its length. So c squared is 45. We'll square root that and we get the square root of 45. Now, here's a pro tip. It is really easy to figure out the diameter and then plug it into the formula for the radius, and vice versa. So in general, whenever you see radius or diameter, a little flag should go off in your head and say, okay, is this the radius or the diameter? And of course, this is the diameter. So we need to take that square root of 45 length and we need to divide it by 2 to get this radius here. So now we have the radius as the square root of 45 over 2. And we have the area of a circle we know is pi r squared. So pi r squared. So now that's pi times the square root of 45 over 2 squared. And that gives us pi times 45 over 4. So 45 over 4 pi, that's our area. So looking back at our choices, we see that our center is -2, 4.5, and our area is 45 over 4 pi units squared.